Bright Duty. Every student matters.
Hello students, chemical effects of electric current. You must have studied till now that what electric current is. Now we are going to study the chemical effects of that electric current. So let us start. Let me give you an introduction to this topic. Students, let us have a very simple example. Do you know why is it dangerous to touch an electrical appliance with wet hands? Your parents must have told you a lot many times that you should not touch an appliance with wet hands, be it any switch, any wire, any electrical appliance, or you should at least wear your slippers, right? This is because sometimes liquids, especially water, not even sometimes, water always conducts electricity. Till now you have studied how to make a circuit which substances like metals conduct electricity. In this chapter we are going to study about the liquids as well. So students, it is dangerous to touch an electrical appliance with wet hands because current can pass through water. Because water is a good conductor of electricity. Right, and hence because it is a good conductor, the current can pass and ultimately you can experience a shock if you use an electrical appliance with wet hands, right? The materials which allow electric current to pass through them are good conductors. As I just told you that water is a good conductor, it is called a good conductor because it allows electric current to pass through it, right? Materials which do not allow electric current to pass through them are called poor conductors of electricity. So there are two kinds of substances, one are good conductors, other one are poor conductors. So the good conductors allow the electricity to pass through them, they allow the electric current, while the poor conductors do not allow electricity to pass through them, right? So now we have understood the concept of good conductors and poor conductors. So and also we have now established that water is also a good conductor of electricity. So there may be other substances, other liquids as well that may conduct this electric current. So let us move forward. Students, till now you must have known what a tester is, but let us recapitulate a little bit. Tester tells us whether a particular material allows the electric current to pass through it or not. Sometimes your parents call an electrician and he puts a tester into the electrical switch to test whether the switch is working or not. If it is working, there is a bulb inside the tester that glows. If that switch is working or the electrical appliance is working, the tester glows from itself. So this is how a tester tells us that whether the electrical appliance or the electrical switch is working or not. So what is the main function? It tells us whether a particular material allows the electric current to pass through it or not. If the electric current is passed, then the bulb glows. If the electric current is not passed, that means that the substance does not allow electricity to pass through it. Right, students? Copper and aluminium conduct electricity. These are metals. Most of the metals have this property in common, that metals conduct electricity, while non-metals do not conduct electricity. There are many substances such as sulfur, oxygen, nitrogen. All these substances do not conduct electricity. Now materials such as rubber, plastic, wood do not conduct electricity. These are again non-metals. They are not metals, so they do not conduct electricity. Now there are two pictures in front of you. This is the first one and underneath it is the second picture. In the first picture, let us see what is happening. There is a circuit. This is the cell, or you can say battery. In the bigger circuits we use battery. Here we have a cell for the supply of electric current. Then we have wires, conducting wires, right? Wire has been wrapped around the cell as well, and between the wires we have a tester. This is the tester, right? This is a bulb. Now when we put a tester and complete the circuit, what happens is through the battery we pass the electric current through its positive and negative terminals. The circuit gets completed by involving a bulb and a tester, right? Now the bulb starts glowing. This is because this part of the tester is metallic and it conducts electricity. right? It is a good conductor because it is a metal. The bottom part of the tester is a metal, hence it conducts electricity and the current is passed through it. Now in the second picture, what is happening? The wires, we are using the same wires, we are using the same cell and the same bulb, but this time we have connected the wires to the non-metallic part of the tester. This is the non-metallic part, and now wires have been connected to the non-metallic part of the tester. Now the bulb is not glowing because this part of the tester has a covering, has a coating of a plastic material on it, and that plastic does not conduct electricity. Hence, in the first picture the electric current was being passed because the wires were connected to the metallic part of the tester, while in the second picture the wires were connected to the non-metallic part of the tester, which is made up of plastic. Hence the electric current was not able to pass through the plastic, so the bulb did not glow. So now we have understood what materials, how can we test for a material that it conducts electricity or not, right? Now students, let us start again with the first topic. As I told you, we will be talking about liquids in this chapter. Before we go into that, we have another small topic, that is testing whether a tester is working appropriately. Right, so let us start. How do we test for a tester that it is working or not? Students, what do? Is you join the free ends of a tester together for a moment, right? This completes the circuit of a tester, right? There are two ends of a tester. Now you have a bulb here, then you have a battery here, right? Now what is happening? You connect both the ends of the tester. This is a tester. You have connected both the ends, hence the bulb starts glowing, right? However, if the bulb does not glow, it means that the tester is not working. This was the case one when the bulbs, this is the tester, this is the bulb, and this is the battery. This is the case one where the bulb started glowing. But in case 2, where there is a case that the bulb would not glow, right? This is the tester. Now the bulb is not glowing. This tells us that the tester is not working. So we simply use the tester, bring it into a circuit, and then after completing the circuit we check whether the bulb is glowing or not. If the bulb glows when we turn on the current, if the bulb starts glowing, it means the tester is allowing the current to pass through it, so the tester is working appropriately. But if the bulb does not glow, as in case second, it means that the tester is not allowing the electric current to pass through it, hence it is not working appropriately, right? Can you think of possible reasons? Obviously, is it possible that connections are loose? There might be some wires which are loose, that we have made connections somewhat loose near the bulb, near the battery, right? Is the bulb fused? That is also a chance that bulb is fused, or your cells are used up. Maybe your battery or the cells that you are using are used up, they do not have much energy to provide. Check that all your connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not, right? Now you have ruled out all the other possibilities of the circuit not working, so that you have replaced the bulb, you have checked the connections, right? You have changed the battery. Even if the bulb is not glowing, that means that the tester is not working, right? So this is how we test for a tester whether it is working or not. So students, let us start with the first activity that we have in front of us, that is testing vinegar or lemon juice. Now what are we doing? Simply we have, this is a plastic cap, right? Now this is a cell and this is a bulb. These are wires connecting completing the circuit, right? Now what are we doing here? To test for the lemon juice or vinegar, what we do is we complete a circuit. We take a cap, plastic cap, and we fill it in with vinegar or lemon juice. Basically both of them have citric and acetic acid. So these are the acids present inside these. Now what happens is, you turn on the battery, the current starts flowing, right? from the positive to negative terminal. You have to take care that these wires should not touch the cap. These wires coming from here, they must not be here, they must be up to the level that they have been shown, that is the correct level. They should not touch the level of the cap, right students? Now what we do, as soon as we turn on the current, turn on the battery, the current starts flowing and this bulb starts to glow. Now why is this? So why is this bulb glowing? It is glowing because the circuit is complete and this liquid present inside the cap is conducting electricity, right? So this is because there are other liquids as well that conduct electricity. So students, as I told you, when we complete the circuit, when there is lemon juice present inside this cap, the bulb starts glowing. Although there are some cases that some of the liquids are good conductors, some of them are not that good conductors. For example, we have vinegar here as well. Vinegar is not such a good conductor because it has no free ions. You will be studying about this in detail in higher classes, that a substance, a liquid only conducts electricity when there are ions present inside it. For example, we have water. In water we have H plus and OH minus. Right, so these are two ions. One of them is positively charged, another is negatively charged. So they cancel each other out in the matter of charges. It is neutral as a whole, but it contains electricity. It conducts electricity because it has ions in its solution. Right. Now vinegar is not that good conductor, so the bulb does not glow in case of vinegar, but it does glow in case of lemon juice, which has basically citric acid present, due to which the lemon juice conducts electricity. So this way, from this circuit we can use water, we can use milk, we can use any other liquid to test for the conduction of electricity by a particular liquid, right students? So this is how we can take a cap and put in different liquids and complete the circuit so as to check whether the circuit is complete and electricity is being conducted or not, right? So students, what is the inference? When the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. What did we see in this diagram? The circuit was complete when there was this liquid inside the circuit. The bulb only glows when this liquid allows electricity to pass through it, right? So this is what we are talking about. The bulb only glows when the circuit is complete, and the circuit gets completed when the liquid allows electricity to pass through it, right students? The current flows in the circuit and the bulb glows, right? The bulb only glows when the current passes through the complete circuit. When the liquid does not allow the electric current to pass, the circuit of the tester is not completed. The bulb of the circuit does not glow, right? The bulb only glows when the circuit is completed and the liquid that we are using in the circuit conducts electricity, because it is a part of the circuit now. The electric current has to move from the battery to the liquid, and then again from the liquid to the wire, and then to the bulb, and hence again to the negative terminal of the battery. So this is how the current runs through a circuit, and for that to run throughout we need this liquid to be a good conductor. If it is not a good conductor, the current will stop here itself. It won't go any further because it won't allow current to pass through, right? So students, due to the heating effect of current, the filament, there are cases when bulb also glows when the liquid is not a good conductor. This happens because I am just discussing that point only. The bulb can glow and sometimes we have a poor conductor as well. Due to the heating effect of the current causes heating effect. The filament of the bulb gets heated to a high temperature and it starts glowing. The function of a bulb only starts when the filament starts glowing, and if the bulb is heated up due to the heating effect of current, the filament heats up and it glows by itself without any current passage, right? So this is how a bulb can also glow. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. If we take any liquids which do not have sufficient ions, the current will be very weak. So that weak current will not be able to make the bulb glow, right? So however, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow, right? Well, though though a material may conduct electricity, it may not conduct as easily as a metal. You can take water, you can take another examples, but metals are the best conductors of electricity. You will be studying about the structure of metals. They basically have kernels, which are the positive ions of metals suspended freely into the structure, and electrons roaming around in the surface as well. They have a sea of electrons and a sea of cations as well. So this is how they have good forces of attraction and they have good amount of ions present, hence they can conduct electricity at a very good pace. They have a very good ability of conducting electricity because of this property only. Now as a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb glow. As I told you in this point, the current through the circuit is too weak, the filament does not get heated up and the bulb does not glow. So in that case, the circuit of the tester may be complete yet the current through it may be too weak to make the bulb glow. So the bulb glowing also depends upon the strength of the current, right? So what have we discussed till now? That liquids conduct electricity and that we can test through by making a circuit. Now students, what are LEDs? LED glows even when a weak current flows through it. You must have these tiny lights at your homes that you use on festivals, on different occasions. These only require a minimum amount of current to glow, right? This is their advantage, that will require very less amount of electric current to glow, right? Only a small amount of current will help them glow. Now students, there are two wires called LEDs attached to an LED. As you can see, this is one LED and there are 1 and 2 wires attached to it, right students? Now one LED is slightly longer than the other. As you can see, this one is longer, this one is longer. One LED is one side is longer. The longer part of the LED is connected to the positive terminal and the shorter part is connected to the negative terminal, right? You must remember by this only. In the battery as well, the positive terminal is represented by a longer line, while a negative terminal is represented by a smaller line, right? So the longer LED, positive terminal of the battery, and the shorter LED, negative terminal of the battery. This is how we make the connections. Now students, we now have an idea about LEDs. Now we have a magnetic tester. Students, magnetism also plays a good role in the production of electricity. You will be studying in higher classes how magnetism is used very much and at a very good pace nowadays in our technology to generate electricity and for other uses as well. Sometimes we generate magnetism, sometimes we generate electricity and vice versa from each of them, right? Now you can look at the picture. What is happening here? We have the base of a matchbox. You can take base of a matchbox, then in the base you put a compass, right? You have the base and now you have put a compass inside it, as you can see here. Now what you do is you wrap it up with a conducting wire, right? Now there is wire all around it. Now what you do is you connect it to a battery and you put any other conducting substance here to complete the circuit. It may be a tester, it may be anything else, it may be a metal as well. Now what happens is, as soon as you turn on the battery, you have turned on the battery. Now what happens is, this compass inside the matchbox, compass shows deflection. This compass shows deflection because of the electric current present inside the wire. So this is how we can test for electric current as well. When we perform this experiment, the deflection that is being seen will only be seen when the circuit is complete, when the current is flowing completely. So this is again a kind of a tester, that when we connect a circuit in which we have a matchbox containing a compass which is wrapped by a wire, wrapped with the help of a wire. This is the conducting wire, you can say copper wire as well, you've used copper wire here, and then you put a compass inside a matchbox, and then you complete the circuit. If you see the deflection in case of compass when you pass the electric current, that means your circuit is complete. All the components are conducting electricity. This is what we're talking about. Basically, this tester also tells us whether a substance is conducting electricity or not, right? So instead of a bulb, we can use a magnetic tester also, in which we have a compass and a matchbox and a conducting wire. And we can also use this apparatus to check for the conductivity of different substances such as water, milk, vinegar, lemon juice, any other liquids you have, salt solutions, right? So this is a kind of a tester again. Now there is a table in front of you. You can use this magnetic tester circuit to test for these liquids, all of them in front of you. Now let us start. First of all, we have lemon juice. Now lemon juice, as I told you in the case of another earlier experiment as well in this lecture only, that lemon juice conducts electricity. So will the compass needle show the deflection? Yes, because it is a good conductor, the compass will show deflection, and it tells us that it is a good conductor. Now vinegar, no, compass needle will not show any deflection, hence it is a poor conductor. Because the vinegar has no ions, the electricity will not be able to pass through it, hence there is no deflection, and hence that is a poor conductor. Now tap water, yes, tap water conducts electricity because it has different minerals, different salts present inside it. It has impurities which make it conduct electricity, so it is a good conductor. Now vegetable oil, no, oils have no ions present in them, hence there are poor conductors of electricity. Now milk also has no ions, so it is also a poor conductor. It basically has organic compounds in it which do not have any ions, so milk does not conduct electricity. Similarly for honey, no, honey also does not conduct electricity. Now we have another examples. We will be discussing about distilled water, and you will learn that tap water conducts electricity while distilled water does not conduct electricity. It is a poor conductor, right? You can take several other examples so as to fit in this table and to understand what kind of liquids conduct electricity and what kind do not. Basically it all depends upon the presence of ions in them, right? If they have ions, they will conduct electricity. If there are no ions, electric current will not be able to pass through the liquid. We need ions to carry the electric current. So that's why ions are very important to be present in a solution for it to conduct electricity, right students? So now what are good conductors and poor conductors actually? Students, actually under certain conditions most materials can conduct electricity. We can create those conditions and the electricity can be conducted by another substances other than metals which do not conduct electricity normally, but we can create conditions under which they can conduct electricity as well. Now it is preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. All of the substances at some point during some experiment or under some conditions conduct electricity, hence we only call them good conductors or poor conductors. Conductors and insulators are not such good terms, right students? So now we are coming to the topic of distilled water. As I told you, distilled water does not conduct electricity while tap water does. Now we will be getting into the difference between both of them. Take about 2 teaspoons of distilled water in a clean dry plastic rubber cap or a cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. Now we are using the circuit again. Basically what was the circuit? You have a battery, you have a bulb, or you can take a magnetic tester as well. Then you have 2 wire terminals into a water beaker. The diagram is pretty small for you. Basically you just have to understand the topic. You have already seen a lot many circuits. Now what happens is you turn on the battery, the bulb does not glow. The bulb does not glow. Why is this happening that the bulb is not glowing? It glowed at the time of tap water because tap water has minerals and salts, while distilled water, at the time of distilled water, the bulb does not glow. It means that distilled water is a poor conductor. Now what you do in the next step is, you now dissolve a pinch of common salt. You have added common salt to the solution, so you call it as common salt solution now. You have added common salt to distilled water, and now we are testing it again. Now what happens is, because we have added sodium chloride, which is the common salt, to the solution, now what happens is this solution now has ions present inside it. Basically common salt is NaCl, and it gets dissociated into ions when it is dissolved in water, right? So when we dissolve it in water, there are ions present, sodium and chloride ions, due to which the circuit gets completed when we turn on the battery and the bulb starts glowing, right? So what did we understand? Let us see. When the salt is dissolved in distilled water, we obtain salt solution. As I told you, we put salt into the water, it becomes a salt solution. This is a conductor of electricity because of presence of ions, charged bodies basically. The water that we get from sources such as taps, hand pumps, wells and ponds is not pure. You can basically say tap water is impure. Right, students? It may contain several salts dissolved in it. Small amounts of mineral salts are naturally present in it. This water is thus a good conductor of electricity. Hence, we can say tap water is a good conductor of electricity. Tap water is a good conductor, while distilled water is not a good conductor. It is a poor conductor of electricity. Distilled water is free of salts and is a poor conductor. This is what we have learned from this experiment, that distilled water does not conduct electricity, while tap water does conduct electricity because of the difference that tap water contains minerals and salts in it. It has impurities which make it a good conductor, while distilled water has no ions present, right? It has no impurities and hence it does not conduct electricity. Now, where can you get distilled water from? You can take it from your chemistry lab, or you can buy from a medical lab. You can obtain distilled water very easily. So students, till now we have learnt that liquids conduct electricity and there are poor conductors and good conductors. We classify them on the basis of the current that can pass through them. If there is a good passage of the current, they are good conductors. If the passage is not good, then the conductor is a poor conductor. Now students, most liquids that conduct electricity are solutions of acids, bases and salts. This is the thing that you have to remember, that most of the liquids that conduct electricity are solutions of acids, bases and salts. Nothing that is organic conducts electricity. Organic as in a glucose solution will not conduct electricity, right? So what are you doing now? You pour 3 clean plastic rubber caps or bottles. Right, you have 3 clean plastic rubber caps. Now what you do next? You pour 2 tablespoons of distilled water in each of them. You have added 2 tablespoons of distilled water in each of them. Right, students? Now what next? Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in 1 cap. Now here you have added dilute HCl, few drops. You know it's an acid. Right. Next, now in the second cap containing distilled water, add a few drops of base such as caustic soda. Right. You have added dilute NaOH here, few drops. Caustic soda is NaOH. Then add a little sugar to the distilled water in the third cap and dissolve it. Now here you have put sugar. In the case 1 you have dilute HCl, that is an acid. In the case 2, that is dilute NaOH, that is a base, and in case 3 you have put sugar, that is neither acid nor base, it is a neutral substance, it is an organic substance, right? It is basically glucose, right? C6H12O6. Now what happens is, you have dissolved the sugar as well. Now you have to connect a circuit and test which solution is conducting electricity and which one is not. So you complete the circuit here only. You just have to understand the concept, it doesn't matter how big the diagram is. So you complete the circuit for each of them. Basically you have to test for the conduction of electricity by an acid, base and an organic compound. Now once you have drawn the circuits, you have to turn the battery on and check for each of the solution whether it conducts electricity or not. Now in the case of acid, as we know, hydrochloric acid dissociates into H plus and chloride ions. So it has ions, basically this is an acidic solution now. So due to the presence of ions, when we turn on the battery, the bulb starts glowing. So what does it tell you? That dilute HCl solution or distilled water containing HCl is a good conductor of electricity, right? So this is a good conductor. Then we have dilute NaOH. Now students, NaOH also dissociates to form Na plus and OH minus into the solution. So this is a basic solution now. As it is a basic solution, it has ions floating inside it. So when we turn on the current, it flows through the liquid and the bulb starts glowing, because dilute NaOH is also a good conductor of electricity. So the bulb starts glowing. Now the third case is when we have a sugar solution. Now we know sugar is an organic compound. It does not contain any ions. It won't be dissociating into any ions when we pour it into a solution. So when we turn on the battery, the current does not flow further from sugar. Sugar is a poor conductor, so there is no passage of current, so bulb does not glow. Hence this is a poor conductor of electricity. So we learnt that the solutions of acids, bases and salts can conduct electricity, but the solutions of organic compounds such as sugar cannot conduct electricity. So students, till now we gave you an introduction of how liquids also conduct electricity, which kind of liquids conduct electricity and which kinds do not. So this was all about the introduction. Thank you for your attention, students.